degrees and turning points of polynomial functions. Our objective: identify the relationship between degrees and turning points of the graphs of polynomial functions. We're talking about the graphs here. So what do we know? Well, we know what a polynomial function is, and we want to remember that when the polynomial function is written in standard form, which means the exponents go from largest to smallest, followed by the constant if there is one, the largest exponent, or the highest power, is the function's degree. We also know that polynomial functions of degree 2 or higher have graphs that are smooth and continuous. If the graph is not smooth and continuous, it is not a polynomial function. So let's take a look at an example. The graph of f of x equals x to the fifth minus 6x cubed plus 8x plus 1. Well, this is a fifth degree polynomial. The largest power is 5. The graph is shown here below. Note that the graph has 4 smooth turning points. We know it's a fifth degree, so the end behavior will be opposite. Okay, and the most it can have with 5 solutions is 4 turning points. Okay, turning points are just places where it goes from increasing to decreasing, or from decreasing to increasing as we read the graph from left to right. So we'll wrap this one up and we'll tell you that a polynomial function of degree n, okay, in this case degree 5, has at most n minus 1 turning points. In this case, 5 minus 1, or 4 turning points. In other words, the maximum number of turning points is 1 less than the function's degree. Okay, 1 less than. Note the words at most. Okay, a fourth degree polynomial, for example, can have fewer than 3 turning points. It will have at most 3 turning points. Let's take a look at these 2 examples of fourth degree polynomials. Okay, the first one is f of x equals x to the fourth. Well, let's graph it. X to the fourth. Okay, I'll graph in my standard window, and you'll notice this has 1 turning point right there. Okay, so at most it can have fewer. It can have at most 3 turning points. This one happens to have 1. Let's take a look at this function, this fourth degree polynomial. I'll go back to y equals x to the fourth plus 3x cubed, and I'll graph this one. And this one, because the way it is here, it has 1 turning point right there. This is not a turning point. It's a little bit of a flattening out there, but it's not a turn from increasing to decreasing. So this fourth degree polynomial has 1 turning point. It will have, again, at most 3, and that's all you know. You know that the maximum number of turning points is 3. Okay, so give me just a moment here, and let's summarize all about that leading term. Okay, the leading term. We learned a lot from the leading term, and I lost my other paper. Here we go. Okay, so now we know that leading term of a polynomial function tells us 3 things. It tells us the end behavior, both the degree and the sign of the leading coefficient tells us the end behavior. It tells us the number of solutions, which we've been calling generally zeros, and it's equal to the number of solutions when multiple zeros are counted separately. And it tells us the maximum number of turning points, okay, all in this leading term. Let's take a look. What does the leading term of the following function tell us about the graph? This is a 6th degree polynomial. Okay, so let's write this down. The leading term is negative x to the 6th. It tells us, number 1, the end behavior. Okay, in this case, both ends go the same direction, and because I have a negative coefficient, both ends go down. Both ends go down. It tells us number 2, the number of solutions. 6th degree tells us I have 6 solutions as long as multiple zeros or solutions are counted separately, as we've seen in previous videos. And finally, it tells us the maximum number of turning points is equal to 5, which is 6 minus 1. So, whoops, I'm a little bit shy there on you. So the leading term tells us the end behavior. In this case, it's an even degree, so both ends go the same direction. It's a negative leading coefficient, so both ends go down. The leading term tells us that it has 6 solutions, with an S there. It's a 6th degree. It has 6 solutions as long as multiple zeros are counted separately. And the leading term tells us there are a maximum number of turning points is 5, which is 6 minus 1. A lot of information from that leading term.